Welcome to this session on the topic Exponents and Powers for the 8th Standard CBSE Mathematics. In this session, we are going to see the laws of exponents and their applications to problems. First of all, what are exponents and powers? Let us see the importance and what is it? What is a power? A power is equal to a number written as a base number with an exponent. Base raised to the power exponent. And it's called a superscript, like this. 2 power 5, an example, 2 is raised to the 5th power. That means 2 is multiplied 5 times. 2 into 2 into 2 into 2 into 2, 5 times. This is called an exponent. Why exponents and powers are important? Let us see. There are some laws of exponents. The multiplication rule, a power m into a power n is equal to a power m plus n. Same base, but different powers. Raised to different powers. We multiply these two, the product rule, that is a power m plus n, we add the powers. A power m divided by a power n is equal to a power m minus n. When we divide two numbers raised to different powers, two same bases raised to different powers, the division becomes a power m minus n. It's a subtraction of the powers. The third rule is called the power rule or exponent rule, that a power m is whole raised to the power n is equal to a power m into n, a power mn. You have to multiply the two powers. The fourth rule is called the reciprocal rule, or the negative exponent to positive exponent rule, which is a power minus m is equal to 1 by a power m. To change to positive exponent from negative exponent, we should take its reciprocal. A power 1 is a itself, and a power 0 is 1. Any number raised to the power 0 is 1. Now we will see the next rule. There is one more rule, which is called the same power but different bases. Two different bases raised to the same power are multiplied. So A is multiplied by B and the result is raised to the same power m. It becomes a power m into a power b power m. So a power m into b power m is equal to a into b whole raised to the power m. You just multiply the two numbers and raise it to the common power. Let us now solve a few questions from exercise 10.1 of the NCERT textbook. Exercise 10.1, fourth question. Evaluate, the question is this. Evaluate 8 power minus 1 into 2, 5 cubed divided by 4 power minus 4. First thing what we do is change the negative exponent to positive exponent in the denominator first. Only this one. So in the denominator, it becomes reciprocal of. So it becomes 2. Because it's 1 by 2 power minus 4, it becomes 2 power 4, and 8 power minus 1 becomes 1 by 8 power 1, which is 1 by 8. So it's divided by 8. Now the next step is to change 8 to 2 cubed, because we have the base 2 in the numerator, so 2 power 4. So 8 is written as 2 cubed in the denominator. So we use the 2 power 4 by 2 power 3, the division rule of exponents, where we subtract the powers. 2 power 4 minus 3 into 5 power 3, of course, doesn't change. 2 power 4 minus 3 is 2 power 1. We just write it as 2 into 5 cubed is 5 into 5 into 5. which is 125. 2 into 125 is equal to 250, and that's the answer to the fourth question. Let us go on to the fifth question. The fifth question is an exponential equation. Find the value of m for which 5 power m divided by 5 power minus 3 is equal to 5 power 5. This is an equation involving exponents on both sides of the equation. We have to solve for m. We have to find the value of m. We have to solve for m. So first we use the laws of exponents on the left-hand side. It will be division rule. We have the division rule or the quotient rule. 5 power m divided by 5 power minus 3. So what do we do? Subtraction of the powers. 5 power m, because the bases are same, 5 power m minus of minus 3. It becomes 5 power m plus 3 on the left-hand side. The right-hand side remains as 5 power 5. So 5 power m plus 3 is equal to 5 power 5. Since the bases are same on both sides, we equate the powers. So when we equate the powers, we have m plus 3 is equal to 5, and therefore subtract 3 from both sides. We can solve this equation for m and get the answer as m is equal to 2 is the required answer. We move on to the next question. The next question is the sixth question. It consists of two subdivisions. Evaluate. Here we have to evaluate or find the value of this expression. Within the brackets, we have 1 power 1 by 3 whole raised to the power minus 1 minus 1 by 4 whole raised to the power minus 1. And the entire thing is raised to the power minus 1. Changing the negative exponents to positive exponents inside the brackets first. So we do the brackets first. So inside the brackets, the 1 by 3 whole power minus 1 becomes 3 power 1. The positive exponent, the reciprocal of 1 by 3 is 3. So 3 power 1 minus 4 power 1. And the whole thing is raised to the power minus 1. Now focus of the inside the brackets, we have 3 minus 4 raised to the power minus 1. 3 minus 4. What is 3 minus 4? Minus 1. Within the brackets. Raised to the power minus 1. Now we change it to positive exponent again. The minus 1 raised to the negative power of 1 is now changed to positive power by reciprocal. 1 by minus 1. It becomes 1 by minus 1 raised to the power 1, which is nothing but minus 1 itself. Therefore, it is minus 1 itself. The answer is minus 1. This is the answer for the first subdivision of the sixth question. Move on to the next subdivision of the sixth question. Second question, this is the second subdivision. 5 by 8 whole to the raised to the power minus 7 into 8 by 5 whole raised to the power minus 4. It's a rather tricky question where we have to use the reciprocal rule of exponents. We change the first fraction to positive exponent, only the first fraction, because we will be getting the reciprocal of 5 by 8 as 8 by 5. And positive exponent becomes 7. Minus 7 becomes plus 7 here. So the negative to positive exponent rule is being applied here. Reciprocal of 5 by 8 is 8 by 5 raised to the power 7 multiplied by the second fraction is left as it is, because we have the same base 8 by 5 all raised to the power minus 4. Using the multiplication rule, now same base multiplied by different powers. That's all. The bases are the same. We just add the powers. 8 by 5 whole raised to the power 7 plus of minus 4, which is equal to 8 by 5 whole raised to the power 7 minus 4, which is 8 by 5 whole to the power 3. And we can evaluate this expression. We are required to find the value of this expression. So evaluate. So we have to multiply. 8 into 8 into 8. 8 cubed. 8 power 3. and divided by 5 cubed, 5 into 5 into 5. So we have 512 divided by 125, which is the required answer. The 7th question and the 8th questions are given as homework. We can easily do this. You can try them. 25 into t power minus 4 divided by 5 power minus 3 into 10 into t power minus 8. First of all, always t is there. So you can use that t, the same base. We can use the exponent rule, because you can change one of the negative power to positive exponent. The denominator t power minus 8 can be brought to the numerator by putting t power 8 into t power 8 there. 25 can be written as 5 squared. And what else can we do? We can bring that 5 power minus 3 to the numerator as 5 power 3 itself. The negative to positive exponent, that is the reciprocal rule. And then simplify. But we have a 10 there. So 10 can be written in terms of 5 into 2, 2 into 5. And then evaluate the expression by properly cancelling the terms. The second subdivision of the 7th question is also a similar type of question. 3 power minus 5. Here again, we have a 10 power minus 5, which can be written as 2 into 5, whole raised to the power minus 5. Since we have the 2 power negative 5 into 5 power negative 5. Positive to exponent rule, then we have the 5 cubed there. 125 is 5 power 3, 5 cubed. And 5 power minus 7 can be, and here again we have a 2 power 2 into 3, because we have 6 there. So 6 is written as 2 into 3. Whole raised to the power, same power, but different bases. So 2 power negative 3 into 2 power negative 2, like that. 2 power 2 into 3, 2 power negative 5 minus 5 into 3 power minus 5. And 3 power minus 5 will get obviously cancelled with the numerator. So like that we can proceed. Try to do that and pin the solution. Okay. So these completes the laws of exponents, exponents and powers. Thank you. Best wishes from Beta Online Learning.